Hello to this second video of the Brassica Practical series. Um, I'm going to give you now a brief introduction to R for those of you that have never encountered the language before. Um, I will assume that you have a little bit of knowledge of what programming is and what a command line is. If you don't, please look it up. There's a lot of tutorials out there. Because today we're going to be doing some programming. So, in case you have never heard of R is an open source programming language that is widely used by a scientific community, which means that it has a lot of code that is developed by scientists in order to solve very specific scientific problems. And that is very useful for us as researchers. Um, the reason why it is so popular, besides of its simplicity and its flexibility, is that it is very accurate for mathematical and statistical purposes. And actually, the origin of R was only for mathematical and statistical analysis, and from there it grew into the current language that it is today. R is designed around data science, and that makes it very powerful. Essentially, I like to think of R as a more sophisticated Excel, in which you can actually program things. So, if you would have tables that you need to do certain operations with, in Excel, you would have to do that semi manually. Whereas in R, you can fully automate the process and have a pipeline that you can apply to multiple data sets over and over. And I think that's part of the great power of R. Another thing that is great in R is its visualization tools. It has both simple but powerful tools for some standard visualizations, but it also has very basic tools in order to design your own visualizations. And that makes R very useful for research because it means that we can show whatever kind of output that we desire. Now, one thing to note is that R and RStudio are not the same thing. So, where R is a programming language, something that helps translate some code into orders for a processor, um, RStudio is what we call an IDE, an integrated development environment. Um, RStudio, in the end, is just a program to help you program in R. So it's not R by itself. For this practical, you should install both R as a language and RStudio in your computer because we're going to be using both. One of the first things that you should know about R is objects and what are objects. In case you have never programmed before, this will also be useful for you because objects are present in almost any programming language. Objects are nothing else than a way of storing data in the most general possible sense you can imagine. A very simple object would be just my first object, which stores a string of characters. In R, we define objects by putting to the left the name of that object that we want to create, then this little sign here that we call the rocket sign, and then the value that we want for that object. One important thing to note about naming is that it's very useful if you put informative names to an object or a variable. I will also call them variables, by the way. It's very useful to have informative names because otherwise, when you afterwards read your code, if all your variables are named A, B, C, and foo, fa, fi, and you don't know what is anything anymore, it's going to be very hard to understand your own code. Naming is case sensitive, so it will be different. R will interpret it as a different variable if you write it with lowercase or uppercase. Names can start with numbers, and generally it is not advised that they contain symbols, except maybe underscores, sometimes dashes and dots. All other symbols tend to have other meanings within the code, and therefore they are not advised to use as naming. Now, objects are important because they have a type and a class that defines what can be done with that object. For instance, numbers can be summed, and strings can be appended together to make a longer string, right? But you cannot sum numbers to a string. So this philosophy of defining types and classes, and those types and classes defining what can be done with an object, is what we call object-oriented programming, and is a very powerful type of programming that is present quite strongly in R. Although R is not by itself an object-oriented programming language. This is all I will say about this today, but if you're interested, I would recommend you reading on object-oriented programming. Now, object types. So, as I said, objects have types and classes. Types are simply the type of information that an object contains. So, for instance, character type is that which holds letters, so just phrases of whatever kind of phrase. And you create them by using double quotations or single quotations. They are slightly different, but for us, it doesn't really matter whether you use one or the other. Numbers can be either integer or floats with decimals. Um, and they can be created simply by specifying the number without quotations. If you put quotations around a number, then it will be interpreted as character, not as a number. It's important. You also have logical values, so you can specify logicals by saying true or false, or the whole word true, or the whole word false, or ones and zeros. Normally, I only use T and F because it's the shortest, without quotations. It's also important. R has also a bunch of different types for missing values, which makes it quite useful for data science, as I had been saying before. But we will not worry about this today because we will not have to deal with it. There are other kinds of type in R. There's about 12 of them, I think. Um, so, for instance, dates or factors or complex numbers, but we don't need to worry about them today either. So we'll be using mostly numbers, logicals, and strings today. So, on the one hand, we have types that define the type of information that the object contains, and on the other side, we have classes that define the data structure, so the way in which this information is being stored. What I have shown you so far were objects that contain one single value, but we can have objects with more values in them, right? There are many classes in R, and classes are super flexible. An object can have multiple classes, and new classes can be easily defined, and many classes exist all over the R language. I will introduce you to some of the basic and more general ones. Vectors, which are simply ordered values. So a vector can contain a series of values. It doesn't matter whether they are numbers or not, but it also contains the order of those values. So for instance, you create vectors by using the function C for combine. Um, and in this case, this vector contains four values, 1, 3, house, and 5.5. And you can ask the vector to return the third value by using these square brackets next to the name of the vector. Then we have lists, and lists are named and ordered elements. So I say elements and not values because actually you can have anything in a list, not only single values, but sometimes lists even, or vectors or matrices. You can put optionally names into it, which is quite useful. You create lists using the list function. You first specify the name. You don't need to add quotations for the name. Then an equal sign and the value. You can do that for any number of elements. And the nice thing of lists is that you can access each element by only using a dollar sign after the name and putting the name of that element. You can also use double square brackets to specify that you want the second element or the third element. You can also put here actually the name of the element that you're looking for with quotation marks if you don't want to use this notation. The last class of object is data frames, and data frames are nothing else than tables. They can have column and row names. They always have column names actually, but the row names are optional. And if you don't provide column names, R will create automatically some for you. You create data frames in a very similar way as you do with lists, using the data frame function, then the name of the variable that you want to create, and you specify it to an object. And here I just created a table with numbers 1 to 10 in the first column, 11 to 20 in the second, and so on. Of course, unlike lists, in this case, each element needs to be a vector and they all need to be of the same length because all columns need to have the same amount of rows. Now, how do you access the elements in a data frame? You can use the dollar sign to get to obtain a column. So using the name of a column um, to obtain that column. You can also use square brackets, and you use the comma to indicate the row and the column that you want. So if you don't put anything, it will assume it's all rows or all columns. The first number is always rows, and the second number is columns. You will have to learn that by heart. And here, what I'm basically saying is, in my data frame, return um, all the rows and only the first column. And in this case, return the first row and the second column. And then it gives only the value in that place. You can also put more numbers than just one in it, and then it will return more values. Oh, damn it. So, now let's talk about functions. A function is nothing else than an object storing instructions that returns a result. So a very simple function is this function sum. And if you give it a series of numbers, it will sum those numbers. Each function expects arguments of specific types and classes, and if you don't provide those arguments, or if you provide the wrong type and class, R will give you an error. They're both mandatory and optional arguments. So for instance, in the function sum, the mandatory argument is the numbers that you need to sum, right? And this argument is called x, and you can provide the name of x or you cannot provide it, and then the functions in R will assume that the first argument that you give is the first argument in its list of arguments. Sum has also an optional argument, now remove, which you can specify or not specify, and if you don't specify, the optional arguments will take default values. And as I said before, you can put the name or not put the name, and it doesn't matter. I would recommend you, however, especially for optional arguments, to specify the name because that would make your code more readable. Last but not least, functions in R are organized in packages. So that means that not all the functions are always available for use. For instance, the function read xlsx is a function that allows you to read Excel sheets, but it is not present in the basic functions of R. It's present in the xlsx package. So if you try to run this function without doing anything else, R will give you the error that it doesn't know where the function is. What you can do is load the library using the library function and then specifying the name of the package, and now all the functions of that package will be available. Sometimes that is too much because the package is too big, or because you just want to use the function one single time and you don't want to load the whole library. So instead, you can use this nomenclature in which you say the name of the package, then put two dots, and then the name of the function. And that lets R know that to find this function, it needs to find this function, it needs to go look in the R package xlsx. Okay, so next topic is the function help page. One of the very nice things of R is that it has a very extensive documentation that helps a lot of people learn how to use R. And each function has its own help page that you can find by typing question mark and then the name of the function without the parentheses. So if you do that with the function sum, you will obtain this help page, and it has several sections that give you different information. First, we have the description that describes what the function does. Then you have usage, and usage is very useful because it shows you not only all the arguments that are possible in that function, but also what are the default values of the optional arguments. So all the arguments that are like now removed here in usage, um, that have already a value assigned to them, it means that that is their default value. The argument section is very useful to understand what each argument means and how you should use them. The details section is not always very well written in base functions, so functions that are very basic. The documentation tends to be very good, but things that some people have developed, sometimes the people don't take a lot of time to write the documentation, and then these sections are not very well written. Then you have the value section, and value describes what output you can expect from the function. Sometimes that is an image, sometimes that is a set of numbers, or some more complicated value. And then you have other sections like references or examples that can further help you understand a function. Now, one of the more powerful things of R, as I said before, is its visualization. Um, and in that sense, there is one function that is core to it. It's the function plot that helps you create plots. Now, plot is not actually a function, is what we call a generic method. And depending on the class of the arguments that it receives, it will use one function or another to create an output. So for instance, if I would provide plot with two variables x and y that contain just numbers, it will create a scatter plot of those numbers and just create a scatter plot. If instead I give a vector that contains a series of characters, t1 repeated 10 times, t2 repeated 20 times, and t3 repeated 15 times, and I turn this into a factor, and I plot this factor, then it will create a bar plot where it shows me the counts for each of the classes that were present in this factor vector. There are some common arguments to all plot functions. Now, visualization is very important in data science, and you might not be very aware of what visualization is or what it means. Visualization is nothing else than translating mathematical properties of data into visual properties. And the objective of visualization should always to make complex data more easily and intuitively understandable. For instance, this very simple example in which we see two distributions of height of two Durham width varieties, it immediately tells us that one of the varieties is generally taller than the other, but that there is some overlap between the height of the two varieties, so the shorter individuals of one are shorter than the tallest individuals of the other. Now, visualization has become crucial in research nowadays, and for instance, this way more complex visualization is giving us a lot of information on just a single image that it would have if it would be described with words or with numbers would be much more complex to understand. Nowadays, visualizations have been crucial for research, and they are necessary if you want to publish something. They are important in reports to convey information. And the more complex information that we use, the bigger data sets that we use, the more important these visualizations become in order to still have a grip, have a handle of that data. With that, we finished our section on R, and I will see you in the next video about the statistical part of the practical.